Fishtank, Unit 8, Lesson 3. In this mini lesson, we're going to learn how to represent data using histograms. So here is a histogram, and it shows the length of a group of adult female sharks. Always important to look at what a histogram is showing you. And I can see that this would be the number of sharks, although they didn't label it, but it is clearly labeled down at the bottom here, the length in feet. Oops, I'm trying to make it so you can see it better. That's okay. This is the length in feet. So I can see that my data is organized by the number of sharks and the length in feet. And in a histogram, one of the things that's a little different is that the data is organized in bins. So this bin right here includes all of the sharks that were between 17 and 17 and a half feet, which looks like it was only one shark. Now this bin here is all the sharks that were between 14 and a half and 15 feet. So here, something kind of interesting and worth noting about these is that you should consider the descriptions of these as using a greater than or equal to and less than symbol. So if we have this bin here, 14 and a half to 15, this would be all the sharks, let's call it S, that are between 14 and a half feet. So they are greater than or equal to 14 and a half feet, but it also is the sharks that are less than 15 feet. So a shark could be 14.999999999 feet long and would fit into this bin, but as soon as they hit 15 feet long, then they would fit into this bin. Let's erase that. We're going to take a look at some questions about this, some true or false questions. So this is the same histogram, and now there's some statements that might be true or false. Pause the video and see if you can answer each of these questions. All right, so a total of 9 sharks were measured. That one definitely cannot be true, because I can see that just in that 14 and a half to 15 foot bin that we were talking about, there were 10 sharks measured. So that means definitely there are more than 9 sharks measured. A total of 50 sharks measured. Well, we can count up how many are in each of the columns to find the total. So 1, 2, plus 4 is 6, plus 10 is 16, plus another 10 is 26, plus 9 is 35, plus another 10 is 45, plus 4 is 49, plus 1 is 50. So yes, a total of 50 sharks were measured. The longest shark that was measured was 10 feet long. This one's addressing a misconception that you might think over here on our y-axis is feet. They really ought to have labeled this. Make sure you label your histograms, but the feet is here. Actually, none of the sharks were 10 feet long. They were all over 10 feet long, because the shortest shark they measured was over 13 feet long, or 13 feet exactly. Most of the sharks measured were over 16 feet long. So I can kind of draw myself a little line here. All right, here are all the sharks that are 16 feet or over. Well, that's definitely not most of the sharks. 2 of the sharks that were measured were less than 14 feet long. So those would be the ones here in these bins, and yes, there's 1, 2, so that is indeed correct. When you're looking at a histogram, you can't tell exactly how long or how much or what an individual data point is. For example, I don't know exactly how long the shark that was between 13 and 13 and a half feet was, but I can tell how many data points fit into a given bin. So a histogram is a really good way to get an overview or a general picture of the data, although it doesn't let me zoom into a particular data point.